Now, in this video, we will discuss about the prime numbers. So, what is a prime number? The prime number is a number wherein it is divisible by 1 and by the number itself. So, to do that, we enter into the Turbo C, we are going to write this program. So, once we want to write this program, so first what is the thing which you want? I want to have the standard input output statement. Why? So that because I want to have the printf and the scanf. So I will say include stdio.h, then include conio.h. Basically this is used for getting the get character functions. So here I will say void main, then I will enter. So what are the things which you want? I want how to declare the variable now. The declaration of the variable is done like this. So here I will enter the number n. So I will take one number. So the n is becomes the variable. Then that number, suppose if I enter n, that is 5. So first what I want to check whether the 5 will going to get a remainder when you are dividing it by 1. Then 5 will going to get a remainder when it is divided by 2. Similarly 5 by 3, 5 by 4 and 5 by 5. If you are getting the remainders every time by repeating it, so naturally I want to enter into a loop. Which loop I will going to take? I will going to take the for loop. So if I take the for loop, I will say I, that is the initialization of the for loop 1. Then what I want, if the number, see what the prime number says, the prime number is divisible by 1 and by the number itself. So you are going to get only 2. The maximum count will going to be 2. So every time I want to count that how many times it is divisible, a given number. So naturally I want to have a count. If I want to have a count, if I want to start the counting, so initial value of count, what should be that? The initial value of count should be equal to 0. So I will initialize that and say semicolon. Then I will say CLR SCR clear screen. Then I will enter printer, enter the number n to be specific. Then read that number scanf %d ampersand n. Read that number. Then I will enter into the loop. So for I is equal to 1, I is less than or equal to n, I plus plus, then the condition is applied. If, what is that? If I enter the value of n as 5, then is 5 is divisible by 5 mod 1 is equal to 0, that is the remainder is there. 5 mod 2, 5 mod 3, 5 mod 4, 5 mod 5. So every time the loop will going to take the increment. So naturally, if I want the number as n, instead of 5, I will take it as n. And every time the number is incremented, so which is the number which is incremented I, because every time the number is divisible by the incremented number. So initialized number I is equal to 1, n% I is equal to 0. Yes, if the condition is true, then you take count plus plus, semicolon, enter, then you close it. Then you come down to this and you close it. So every time it counts. Once the count is done, now it comes out of the loop. So when it is going to become prime, when it is divisible by number itself and 1. So how many counts you are going to get? You are going to get 2. So now the condition is, I will apply, if count is equal to 2, then the number is prime, otherwise it is not a prime. So if count is equal to 2, then what is that? Printf the entered number percentage d equals not prime. N. Then else, if the condition is not true, printf the entered number %d equals not prime n, semicolon. Then you get ch function and say close. So this is how you will be able to write the program. Now we are going to run this. We will say how many times enter the number n. I will say 5. The entered number is prime. Then I will say entered number is 10. Suppose I will say it's not a prime number. So this is how you will be able to execute. Now we are going to understand how the loop is working when you are going by the step-by-step sequence. I will press F7, function F7. So I am declaring the variables and enter the number n, and I want to read the number. I will say 5 initially. Then, so I is equal to 1, that is the initialization is done by using the for loop. Then it checks the condition. I is less than or equal to n. Yes, that means 1 is less than or equal to 5. Yes. Then condition is, so we have n and I. So every time n has to be checked with the number which you have taken from the initialization of for loop. N mod 1 is equal to 0. That means 5 mod 1 is equal to 0. That means the remainder is 0. Condition is true, so count will be equal to count plus plus means what? Count is equal to count plus 1. Initial value of count is 0 plus 1, so the count becomes 1. So then it goes for the increment is 2. Then it checks for this condition. 5 mod 2 no is equal to 0. No, the remainder is not there. So it skips that and then comes to F3, that is 3. Is 3 is less than or equal to 5, condition is true. So 5 mod 3, again it is equal to 0. No, it again skips that and goes to 4. Is 4 is less than or equal to 5? Yes. Again checks for the condition. 5 mod 4 is equal to 0. No. Then it increments, becomes 5. Is 5 is less than or equal to 5? Yes. It comes into the loop. Again 5 mod 5 is equal to 0. Condition is true. So it enters into that. So count will be what? Count will be equal to count plus 1. So what is the previous value of count? The previous value of count is 1 plus 1, it becomes 2 now. So that means it is divisible by 1 and the other number is only 5. So the count becomes 2. So again it goes for the function. Is 6 is less than or equal to 5? No, it comes out. Then it checks for the condition. What is how many number of counts you have now? The count will be equal to 2. Is 2 is equal to 2? Yes, the condition is true. So the entered number is a prime number. So naturally the getCH function, so the entered number is prime. Now we want to check the other one for not prime. I will just take any count. I will take the value as n, as 10. So I will go for the step by step. So enter the number same way what I have explained. I will take 10. Then I is equal to 1. 1 is less than or equal to 10. 5 condition is true. So 10 mod 1 is equal to 0. Yes. Count becomes 1. Then it increments 2. 10 mod 2 is equal to 0. Condition is true. It becomes count is equal to count plus 1. It becomes 2. Then takes 3. 10 mod 3. No. 10 mod 4. No. 10 mod 5. Condition is true. So count it becomes 1, 2, 5. So we got 3 now. Then again count 10 mod 6, no. 10 mod 7, no. 10 mod 8, no. 10 mod 9, no. 10 mod 10, is equal to 0, yes. So it becomes count 3 plus 1, it becomes 4. Then 11 is less than or equal to 10, no, it comes out. Then it checks for the count. So how many counts we have now total? 4. Is 4 is equal to 2? No, the condition is wrong, the condition is false. So else it becomes the entered number is not a prime number. So this is how you will be able to execute the program on, it's the program on prime number, whether it is given number is prime or not. So I am going to come out of this, I will say alt F, put, save changes, no. So it is going to come out. So this is how you will be able to execute the program. Thank you.